Hey folks, how's it going? This is Mr. Murray coming to you with a do now video. Okay, so in this do now, we're going to take a look at this triangle here, and this is following directly from the law of signs ambiguous case that we discussed yesterday in the 316 lesson, and which you can find in the 312 handout. Okay. All right, so in this do now, what we're doing is we're going to find the measurements of the triangle or triangles such that M is measurement of A is 23 degrees, little a is 14, and little c is 20. So in this case, you have a side, and an angle. In particular, all right, the angle opposite the given, rather the side opposite the given angle. So the S and the A really are paired up with each other. Okay, so take a moment, try to find the measurements of any triangles that meet this description, and then when you're ready, unpause, and I'll break down the solution. All right. So let's start by taking a look at it. And again, if you haven't seen the video from the other day, I really recommend you go ahead and take a look at that from the previous lesson. Okay, so what we learned is that if I'm given a triangle, and let's say I know one of the angles, I know an adjacent side, and I really have the freedom to call it whatever I want. And let's say that I know some other side. For example, we're going to call this A. Well, what I essentially have to do is I have to look at the height of the triangle, and I have to look at how A compares with B. In this case, I'm actually given C. So if I was to label this triangle, how I really should label it, get that out of there, is this would be A, big A, this would be big B, this would be big C, somewhere on this line. We don't know how long it is because, actually how long B is rather, because we're in the process of solving it. Okay, so that's our little c. Now in the picture, this was called B in your 312 notes. Okay, again, this is from 312. So what we know is that if A, the unknown side, is bigger than this known side, then we're going to likely have one triangle there. If it's smaller, then essentially it depends. Well, first of all, if it's equal to the height, it will snap down as a 90-degree angle. It'll become a right triangle, and then all your old rules about sine, cosine, and tangent apply. If it's less than the height, like this one kind of looks like, it will never actually touch the final side, so you'll have no triangles. And if it's more than the height, but less than the given side, what happens is you get a phenomenon. I'll do this for St. Patrick's Day, where you either snap one way or snap the other way. And that actually leads to two possible triangles. So we have four scenarios. We have A is equal to H, one triangle. We have H is less than A, which is less than C, the side opposite the given angle, the other side given. We'd have two triangles. We have A is greater than or equal to C. We're going to have one triangle. And then we're going to have A is less than H, and that will go with no triangle. So let's see what happens. So far we know that A is definitely, we can see it's 14, C is 20. It's not this. So let's go ahead and take a look and see if we can figure out H. So the height of this triangle will be equal to, here's 23. It's going to be equal to 20 sine of 23. And if you don't know how I got that, think about the fact that sine of 23 has to equal the opposite, H, over 20, and think about how I'd get h alone. Okay, now in this case, we're going to use our calculator, making sure we've set it to degree mode. Okay, so 7.81, I'm going to hit mode real brief. You can see it's set as degree, so I'll second mode to quit. So I have h is approximately 7.815. So a is not equal to h, right? 14 isn't equal to 7.8, but it's more than that and less than there. So we're in a scenario with two triangles, okay? So what we have is this. We have one, it could either look like this, or instead of snapping back this way, it snaps forward this way. Okay? So here's my A, my B, my C, or my A, my B, my C. So I always like to fill in the known information again. We know A is 23 regardless. We know C is 20 regardless. We know A is 14 regardless. So these are all known. And that's never going to change. So we might as well fill that in. And I'm sorry, I want to make sure I've got the right A there. Okay. Now I'm going to go ahead and I'm going to box in this. And the reason I'm doing that is because that is my known information. One of the big takeaways from the video I did on law of sines is that you never use any kind of guesstimates when you're solving with law of sines. For example, in a moment, I'm about to calculate big C. When I do that, I'm going to have to use inverse sine. Okay, and when I use inverse sine, what's going to happen is that I'm going to get not a whole number most likely. And when that happens, I need to do some rounding. Okay, and so when I round, I'm going to have to round it to probably maybe 2, maybe 3 decimal places. Okay, and so I'm going to be putting in an answer that's not really the right answer. It's like it's an estimate, right? It's a rounding. Okay, so to find C, what I know by the law of sines is that the sine, let me do this in blue. I know that if I take the sine of C and I divide by its corresponding side length, which is 20, what I have to get is the sine of 23, which is the sine of A, over its corresponding side length, 14. Okay, so what that means is that the sine of C is equal to, if I multiply that 20 up there, 20 sine 23 over 14. So C is equal to the sine inverse of 20 sine 23 over 14. And you have to use your calculator. So second sine inverse, 20 sine 23 over 14. All right, what I get is C is approximately 33.9. Let's call it 9.3. Okay, so that's the smaller angle. But remember, it kind of like splinters here. So I have this angle and this angle. We talked about how this is effectively an isosceles triangle, so that if these arrows I'm pointing to, these angles are the same. And so if this arrow on the left represents the angle, or points to the angle, it's 33.93. The one on the inside, the other C, I guess we'll call it C2, has to be the supplement of that. So I'm going to do 180 minus 33.93. What that gives me is 146.07. Okay, so it's going to create right now two triangles. Okay, one where I have 33.93 and another one where I have 146.07. Okay, So first of all, if C is 33.93, then B is 180 minus 23 minus 33.93. In other words, 123.07. Okay. On the other hand, if C is 146.07, then C is jet black 10.93. Okay, so there we go. That's the remainder, because remember the three angles. So now when I add up 23 plus 123.07 plus 33.93, I get 180, and 23 plus 10.93 plus 146.07 also will equal 180, and we know that all triangles add up to 180. Okay, so now's the uncomfortable part. We now need to find little b. Okay, so to find little b, we need to set up a law of sines. So you know that in one case, let's do the blue case on the left. The blue case is when we have 123.07. Okay, and the black case is where we have 10.93. Okay, that's our b value. So we shouldn't use estimates. We're going to have to, because for b, because we have no choice, but we're going to choose the sine of a. So I'm going to do sine of 23 over 14, because that's the exact value, right? And so for b, little b, we're going to get an estimate, and you don't want to use an estimate like c to find another estimate like b. Okay, you want to minimize the amount of inaccuracy, because that inaccuracy propagates or works its way out to further inaccuracy. Okay, so you want to minimize that. Okay, so it's equal to the sine of, so if b was 123.07, okay, it would be on the right. You can see c is rather small, b is a little bit bigger, over little b. So what I get is I get b sine of 23 equals 14. This is from cross multiplication, right? We kind of brushed up on that in the similarity unit. So b equals 14 times sine 123.07 over sine of 23. So let's run that. So this has to be done in a calculator. Again, please seek out Wolfram Alpha. Wolfram, WOLF, like a wolf. Ram, like the ram. Alpha, like the Greek letter. Okay. .com. Really important. You need a way to do this if you don't have a calculator at home. So 14 times sine 123.07 divided by sine 23. I get b is approximately 30.0. That's 30.03. So that's case 1. You can see that makes sense, right? It should be the largest because it's across from the largest angle. Now in this case, it's going to be the smallest because it's across from the smallest angle. Okay? All right. So now let's solve this one. It's going to be the same idea, right? So we start with the sine 23 over 14, and that's got to be equal to the sine. Now this time it's 10.93 because that's the angle opposite over b. So we'll get b sine of 23 equals 14 sine of 10.93. We divide by sine 23, and we get b equals 14 sine 10.93 over sine 23. Hopefully someone's come up with a better way to do this by now. One of you guys, I bet. You guys are pretty smart. You can figure that out. So notice though the similarity here. Basically it's the same. I got a 123.07 and a 1093, but otherwise they're the same. So I'm just going to save myself time, and instead of writing the 123, like, I'm not going to waste my time on this right here. What I'd rather do is I'd rather do the 10.93. Delete that because I don't need the extra digit. Run it again. Right, same idea. And let me just do this in the right color here. B is about 6.79. So you can see in this case, it goes from being the largest across from the largest angle to the smallest across from the smallest angle. Okay, so really we have two solutions. The first one is that A is 23, B is 10.93, again that's an estimate, C is 146.07, little a is 14, little b is 6.79, little c is 20. The second solution is that big A is 23, big B is 123.07, big C is 33.93, again all degrees, little a is 14, little b is 30.03, and little c is 20. Okay, so there's two solutions, two possible triangles. And remember, with law of sines, you have to do both if both exist. And both exist only when you have SSA, another arrangement for that, the word we don't like to say because we don't swear in math class. But that's where the issues come in when you have that information. Today we're going to take a look at law of cosines, and in law of cosines, you typically are not going to see this happen, though you do also usually need different information, so we'll have to take a look at that. Okay, so hopefully you found this video to be informational. Again, I really highly recommend that you take a look back through anything you need to take a look at, all right, including the notes and the slides from and the video from last time. All right, so just keep it up, keep working at it. Send me the questions. Remember, you can reach me at rmoray@miltonps.org, or you can reach out to me on the reminder, etc. Okay, so stay positive though, and remember, you can do it. Okay, keep it up. I'm looking forward to hopefully having a little Blackboard, or not Blackboard, a little Google Hangout soon. All right, so we can have a chance to ask questions. All right, but keep it up. Don't forget to love math, and have a wonderful day.